morning, ladies and gentlemen. John Belkowitz from Intelligent Concrete. We're starting up our coffee talk back again. Apologize for being gone for so long. We've been concentrating on our 365-day project, and it is doing great. If you haven't seen our vlog on YouTube channel, check it out. We've got some great information there. This coffee talk goes out to El Khalil. We had recently published an article on soft water attack. What is soft water doing to concrete? And El Khalil asked a great question. Nice article. It's the first time I've known this type of concrete chemical attack. Thank you very much, Dr. Belkowitz and Mrs. Mallory. I have a question. Can you explain more about the aggressiveness of soft water attack? And to give you sorry, let me mute this. To give you an explanation of what soft water attack is, normally caused by water that is adjacent to a concrete structure that has a low ion content to it. And concrete has a ready supply of undissolved and dissolved ions through calcium hydroxide. So with this low ion content water being adjacent to the concrete structure, the calcium hydroxide is going to leach out of the concrete. Now what that does is it's basically tearing apart the hydrated cement matrix from within and, breaking down that composite structure of concrete. And Al Khalil's question is, how aggressive is this attack? Now, looking at it on a holistic scale, when we compare how aggressive is soft water attack compared to de-icing salt, de-icing brine attack, or alkali silica reactivity, or acid attack, it's not as prevalent, but where it does happen, it can be something that leads to more aggressive attack. The biggest problem with any type of ion or electron acceptor is that it breaks down the hydrated cement matrix and compromises the structural integrity of that concrete composite. So what we end up getting is a concrete that is more permeable, has more cracks to it, is more susceptible to the migration of more deleterious materials, and or susceptible to physical attack like abrasive wear, underwater, vehicular traffic, whatever the case may be. That soft water attack might not be the primary mechanism for concrete failure, but it's going to lead to other things. So let me separate that again. The first thing is we don't see soft water attack as prevalent as some of the other concrete attack mechanisms like ASR, de-icing salt, steel corrosion. So it's not as aggressive as those, or we just haven't seen it as much. And then the other piece of it is, how aggressive is it to leading to the failure of the concrete structure? And, that one I led into that it's going to be lead to more aggressive attack or make the concrete more susceptible to more deleterious material or physical attack. That being said, if the in-place concrete that was initially placed is what's the word I'm looking for? Is a subpar concrete. If it wasn't a good concrete to begin with, then while soft water attack might not lead to premature concrete failure or total failure, a concrete structure, thinly made concrete structure with subpar concrete might be susceptible to premature failure from soft water attack just because it's not that good of a concrete to begin with. So I hope it answered your question, El Khalil. I appreciate it. Great question. Thank you very much for the response and the engagement. Please let us know if you have any other concrete questions or concrete concerns. Don't forget, we're the concrete experts. Go concrete, beat asphalt. Have a great day.